Hello, pre-algebra students. Welcome to class. Or as I usually say, good morning, mathematicians. Let us take a couple deep breaths and say a quick prayer, and then we'll jump into our work for today. All right? Heavenly Father, we thank you for today. We pray that you be with us, Lord, amidst all the different things that are going on in the world now and in our own individual lives. We pray that you be with us as we gather together now via video to learn this lesson, and pray that you would give us wisdom, give us understanding, and help us to do a good job in our studies while also keeping everything else in life balanced, God, and staying healthy as well and staying sane as we're kind of stuck at home. God, thank you that your love transcends everything and that we are safe and secure in you. And be with us in Jesus' name. Amen. All right, students, so we are in chapter 9 right now, which is on what topic? Statistics. And we are in the second section for statistics right now. So in the first section, we reviewed what the mean, median, and a little bit of the mode are. Remember, mean is the mean one that makes you add them all up and then divide by the total number of numbers. So it's kind of mean because it's the most work, but we're allowed to use our calculator for that in this chapter. And then the median is the one that's in the middle. And we even learned about quartiles as well. The quartile, the first quartile is the one that's in the middle of the first half of the data, and the third quartile is the one that's in the middle of the last half of the data. And so that's good stuff there. We learned about the interquartile range, right? And then the total range of all the data. And we're going to be continuing to learn about those things, but today we're also going to learn about one way to represent the data. You might have seen data sometimes represented as like in a bar graph, for example, or in different ways, but we're going to learn how to organize our data in a stem and leaf plot for today. All right? So when you think of a stem and a leaf, you probably think of flowers, and in fact, we're going to turn to our note sheet now to see what that looks like. Probably going to make you dizzy, but sorry. All right. Hopefully you didn't throw it. Okay, so here we are. We have our beautiful little flower. And as you can see, this is the stem of our flower right here, leading all the way up. These are the roots. This is not a botany lesson, but all right. And then these are the leaves that are on the stem. Now, for a stem and leaf plot, where the leaves are is very important. If this 5 and 8 leaf were actually down here, is 5 and 8 down here, that would mean something very different. So the location of where the leaves are, where in the stem the leaves are, is going to be very important. We're going to get down to the big picture down here in a moment, but let me also show you this one, which I found online and also like. This shows a little bit more about what this actually means. If these are our stems, so this is different data here, and here the leaves are kind of represented all on one leaf. Technically, I like this one more because each number here is kind of a leaf. But anyway, this actually shows us what it means. So in this and in most standard stem and leaf plots, but not in all of them, the stem, the digit in the stem is the number of tens. So this would be 2 tens, and then the leaves are the number of ones. So this digit right here means 2 tens because it's next to the 2, and 1, which means 21. This 2 here means 2 ones, but it's in also the 2 tens column, so it means 2 tens and 2 ones, which is 22. This one also means 22. This one here means 25. Now this 5 way down here does not mean 25. This stem is in line with the 5s in the tens column, so this stem means 55. This leaf right here, sorry. This leaf right here, let me think of another example. Are any of the other digits repeated? Not really. They're all unique from here on out. But so this 0 doesn't just mean nothing. It means no ones, but 3 tens. So 3, 0, 30. This 3 means 33. This 7 means 37. And then this 7 means 37 again. So in terms of modes, we have 3 modes here. We have 54 is repeated twice. That's a most often. Another mode would be 37. We got 2 of those. And another mode is 22. We've got a lot of different data points here. I didn't underline all of them, but that's what each one of these digits mean. Okay. Now there's one major error I just want to comment really quick here, which is that in this stem and leaf plot, they just skipped right over the 4. Did anybody notice that? We've got 2 tens, which is 20, 3 tens, which is 30. There's no 4 tens. So if this was actually going to be a totally legit stem and leaf plot, they would have had the number 4 here with no leaves next to it. Little lonely 4. And then the number 5 would be down here with all of these leaves next to it. We would see a gap, which really would help us visually understand that there's a gap in the data. There's no numbers between 37 and 51. That's a pretty big gap. So this is the visual for an actual stem and leaves coming off to help us understand which is which. And now we're going to go ahead down here and look at this nice big picture here. All right. So what we want to understand is that this plot right here, this basic plot with the stem and the leaves here, actually represents data. And in this picture as well, the original data set's actually given to us. It's really nice because this is already in order. So I'm going to write in order with the check mark. You don't want to get tripped up by not having your data in order. This is already in order for us, so it's going to make our job easier. And in this case, again, our stem is going to be our tens and our leaves are going to be our ones. So we can even write that here. That's kind of nice. But what we usually do is actually make a key. And for our key, we do the first stem, which is 0, and then its first leaf, which is 4. And we do a line because there's a line here. And our key tells us that 0 line 4 represents what? It represents 0 tens and 4 ones, which is 4. And what is our unit? Our unit is, does it even tell us here? It just gives us our data set. Maybe this is for apples. Because maybe people were surveyed and asked how many apples do you eat each week, and some people said they only ate 4 apples a week, and some people said they ate 35 apples a week. Okay, that would be a lot, so maybe it's not apples. But anyway, you do want to include your unit in the key if that information is given. Okay, so do we see now, folks, how this 4 here represents 4? This 4 here represents 14, which would be this data point here. So even though the leaves look the same, this leaf is a 4, it's connected to the 0 stem, so it means just 4. And this 4 here is connected to the 1 stem, so it means 1, 4, or 14. Okay? As this points out, if I ask you what's the mode, what appears most often, you might say 3 because there's 3 3s. But each 3 listed represents the data point 33 because it's next to this 3 here. It's in this stem row. So 33 is actually the mode in this case. 33 is the mode because it appears most often. So, oops, mode is what I meant to write. Now, I don't want you to get tripped up because you see there's 2 8s there, and let's pretend just for a second that there were 2 data points that were 28. Just for a moment, I'll write them in. So you might be tempted to say, oh, there's 1, 2, 3, 4 8s, so 4 is the mode because it occurs most often. But, wait, so 8 is the mode because 8 occurs most often, sorry. But that is not the case. Can you think of why? Because these 8s represent the number 8 with 0 tens. But these 8s here represent 28. So this, in my modified data, when I add some 8s here, I'm actually adding 2 28s because of where I've placed the 8. If there were additional data point that made an 8 be here, then that would be 18, would be that data point. Okay, so hopefully I've made that point, that the leaves are very much connected with the stems, and that's important. It might be a little confusing. You might wonder, why don't you just write 14 and 15 here instead of 4 and 5? And I don't know, it's kind of a valid point maybe. But this is how we do our stem and leaf plots. You can take a moment to read some of this other words here if it's helpful for you to see that. But at this point, I'm going to go on to some more examples. And actually, we're going to try, as I pointed out here, these are tens and ones, and that's quite common. That's probably the most common place value for our stem and leaves. But we're going to do another example here, where actually when we look at this data wouldn't fit well in a stem and leaf plot that had tens and ones, because none of these have any tens. They all have ones and tenths. So what we're going to do here for our stem and leaf plot is we're going to write stem and leaf, or leaves, it doesn't really matter. I'll write leaves. And in this case, our stem we want to have be our ones. And our leaves are actually going to be our tenths. So we don't even really have to write that up there, although I like to. In the key, what we really need to do is pick the first number and explain what that means. So first, let's go ahead and check that all our data points are in order. So great, I'm actually going to write in order check, just to kind of say I did make sure I did that. And we're going to go ahead and actually make our own stem and leaf plot given this data. This is data that Sam got his friends to do a long jump, and he got these results. And actually, it doesn't even say what units he got. So what do you think? Are these inches for a long jump? Feet? Maybe these are meters or yards. Let's go ahead and call them meters. 5 meters would be pretty long. This guy was really good. 2.3 meters wouldn't be too hard. So we'll say that our units are meters. I'm going to add that in. So we can see we have a number of data points that are just in the 2 range. We got 5 there. So I'm going to make a stem of 2. And then my leaf for this first one, for 2.3, I'm going to represent that with the 3 in the leaf column. And I'm going to go ahead and indicate in my key 2 line 3 means 2.3 meters. Okay, now we're going to put 2.5 on our stem and leaf plot. We're going to put that as a 5 here. Let's leave a nice little space there. We've got another 2.5, so it's going to be 2.5. And in fact, it's actually sometimes helpful to just cross them off as soon as you write them down. So I wrote down those 3 data points so far. Then we have a 2.7, so in the 2 row, I'm going to put a 7, cross it off. 2.8 means an 8 in the 2 row. Cross it off. All right, now we're going into the 3s. And we have 3 data points there. So I'm going to put a 3 here. I'm going to leave room for a 4 and a 5 because I see 5 is the highest I go up to here. So for 3.2, I'm going to represent with a 2 in the 3 row. 3.6 will be a 6 in the 3 row. And the other 3.6 will be a 6 in the 3 row. Now notice how I've got these really nicely lined up. That's just helpful visually and space-wise. You can see that there's more 2s than there are 3s. There's more leaves in the 2 row than there are in the 3 row, I'll say. And 4.5 is the only thing in the 4 row, so I'm just going to write a 5 right there. Now notice I'm not going to put the 5 over here to be in line with the 5s. No. We're just always going to put them right next to our line here. And 5.0, I'm actually going to put a 0, it's 5.0, in the 5 column. So now I think I'm done, but folks, let me give you this huge hint. You always want to make sure that you have the correct number of data points and you've not left anything off. I will tell you this is one of the biggest errors that you want to avoid. So n, our sample size, which we always use the letter n to denote, is what? Well, what's our sample size? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. So Sam must have had 10 friends to do this long jump. So let me go and make sure. Do I have 10 data points represented on my stem and leaf plot? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, I do. So I got all of them. Awesome. I checked. There really are 10. Now you might be tempted to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, but that is not correct. We're not going to actually count the stems. And hopefully that goes without saying, and none of you were tempted to do that, or at least now you understand why not to. But this 2 doesn't represent anything on its own. It's just the 3 that represents 2.3, and the 5 that represents 2.5. So we're not going to count the stems individually. Okay? We only count the leaves when we're looking at the number of data points that we have. All right, so that's an example of how to make your own stem and leaf plot given data. And again, a lot of times when the data is given to you, it's not going to be in order, so you're going to want to be very careful about how to make your plot so that you get every data point and that they are in order. So you would never want to have the 3 be over here after the 8 or something. You always want these to be in order. Let's take a look again, kind of just to get the idea of what a stem and leaf plot kind of can tell us visually. All right, so that's what this example down here is. So we're looking at a table that's the math scores of 41 students. So I guess that means that n is 41. If we counted up all the leaves, we'd have 41. And this is what the stem and leaf plot looks like. Now, is this a 0.4 or is this 0 tens and 4 ones? Oh, let's take a look. Oh, it tells us here. The notation 2 line 4 represents a stem 2 and a leaf 4. And to tell you the truth, I don't love how this is done. So for our keys, let me teach you a different way. We just kind of by tradition, we take the very first point, the very first data. So we're going to do 0-4. That's how you're going to make your key on your homework as well. And you're going to say 0 line 4 represents, and in this case it's going to be, you're just going to say 4 points for the math score. That student earned 4 points. Ouch, they didn't do so well. So we have the number it represents. This is not 0.4, it's just 4, and we have the units that they're points. Okay, but so you can see there was this one student who only got 4. The highest score was a 67, represented by this leaf here. And there were a bunch of scores in between. What do we think for the mode? There's 3 zeros here, so it looks like 50 is the mode. We could figure out a number of other things, but for now what I want to just say is, let's look at this, which is the stem and leaf plot, and let's turn this way so that we can see we got just a little bit here, we got more here, we got a lot up there, and then not as many there. Do you see how we can kind of do that? And that's actually what's been done right here. This data and this data is exactly the same. It's just that it's been turned on its side. And this is something that we're a lot more familiar with seeing, that maybe we'd see something like these are the students that scored between 40, actually this would be between, if it's in the 5 row, between 50 and 60. And then this row, this column here, it's a column because it's upright, would be 40 to 50. And then this column here would be 60 to 70. That's something we're a lot more familiar with seeing, right? And we can see in the general shape that kind of the 50 to 60 range was the most common. And we can see that there's some stragglers kind of on the left, but for the most part the data is kind of over here. That means that this data has a skew. S-K-E-W. It's kind of skewed to the left because there's kind of stragglers or outliers on the left. So this is skewed left, we would say. A lot of times in real life, the data, well, not a lot of times, but, well, when you get to stats course, a lot of times you're going to talk about a normal distribution of data where there's a little bit on the left and the right, but for the most part there's this nice big hump in the middle, and it's totally symmetrical and there's no skew at all. But sometimes it is skewed a little bit. Here there's this kind of tail, we call this a tail on the left, so it's skewed left a little bit there. This is one of my most common mistakes. Sometimes I want to say that this data is skewed right because most of the data is on the right-hand side, but that was one of my common mistakes for a while when I was learning this, and now I've caught my mistake, the error of my ways. All right, yeah, and we can see that there's a single peak going on here. So that's kind of one thing you can think about when you see the stem and leaf plots, is you kind of can imagine them turned on their side. Okay. The next thing I want to point out is actually what I was kind of trying to draw out there is here. This is a nice histogram here. And so, let's take a moment here to think about what I want to say. Okay. So In this box here, I want to point out that there's some data points here, and again, these are in order, so I'm just going to even write that. You want to get really good at checking to make sure, are they in order or do I need to reorder them myself? So this is the data, and each one of these three things here is representing this exact same data, so that's kind of interesting. This is a frequency table, or a frequency chart. I'll call it a frequency table. And we can see that between 10 and 19, there's 2 data points. So that's what the 2 means there. Between 20 and 29, there's 2 data points. Between 30 to 39, there's 4 data points, and so on. So that's what this frequency table is showing us. That's actually exactly what this histogram is showing us as well. That between 10 and 20, or technically it's really just between 10 and 19, because if it was 20 exactly, you might wonder, well, if it's 20 exactly right on this line, do I put it over here or over here? And the convention is we always put it in the next column over. So this is 10 up to 19.99 would go in this column here. So again, this shows us that there are exactly 2 things in the 10 to 19 range. There's 2 data points in the 20 to 29 range. There's 4 data points in this range here, and back to only 3 in this range here. That would be those final 3 here are represented there. So that's kind of nice. And then lastly, you'll notice again, there's 2 in this range, 2, 4, and 3. But this stem and leaf plot, okay, so there's kind of 3 different titles for these 3 different representations. The stem and leaf plot actually shows you what are these 2 data points. It shows you that they're 12 and 13. And it shows you that the 2 data points here are 21 and 27. Indeed, these 2 right here. So, in terms of which way retains the most information, that would definitely be the stem and leaf plot, because you can see exactly what those data points are. For here, we don't know what these 2 points are. They could be 10 and 10, or they could be 19 and 19, or they could be anything in between, really. But here, we actually can see that the data points are 12 and 13. So that's one advantage to the stem and leaf plot. But do you see how they're all related? That's my point in showing you this box here. All right, let's move on to the next page. And this makes a point that by looking at a stem and leaf plot, you can determine all of these important things that we've been talking about before. You can determine the mean, the mode, the median, the quartiles, the interquartile range, the total range, the outliers, and the sample size. So we will be talking about that down here in just a moment. Actually, let's talk about that down here right now, okay? So first, I want to define what outliers are. We'll skip this box for a moment. Outliers are data points, this is my very rough definition, that are kind of outside. They're kind of far away from the rest of the data points. They're kind of out there. All right? So when we look at this stem and leaf plot here, we can write stem and leaf. We can see that there's a lot of data in here in the kind of the single digit numbers, and then in the 10s and in the 20s. We've got a lot of data that's falling in there. But then we have these 2 digits, 45 and 47. These 2 leaves here representing 45 and 47, which are kind of out there. So, and we can actually see, because this stem and leaf plot did a good job of putting 3 in the stem, even though there's no data points representing 3, right? So we can see there's kind of a big gap here. It jumps from 23, which is the maximum, the highest value, not including the outliers, to then 47. Or from 23 to 45 and then 47. So that's a big jump. So that means that these guys here represent outliers. Now outliers could very easily be on the lower end as well, but in this particular data they're on the upper end. And outliers can really affect our data. So we are going to do an exercise here where we calculate all of these different numbers for this data here. Now, if you wanted to, you could actually write out 2, 2, 3, 4, 6, and then 11, 12, 20, 20, 23, 45, and 47. You could write all those out, and that might help you, but I'm actually going to show us how to calculate these values without having to write all that out and just going straight from the stem and leaf plot. So let's go ahead and calculate the sample size, or figure out what the sample size is first. That's always n. What is n? How many data points do we have here? I'm going to have you go ahead and count yourself. Okay, I counted and I got 12, because we're going to count each leaf. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our sample size is 12. All right, we already calculated the outliers here, which is 45 and 47. Again, don't fall. This is so common to accidentally say the outliers are 5 and 7, but this is 45 and 47. All right, we can also calculate the range. That would be an easy thing to do. So remember, the range is from the min to the max. So let's actually just go ahead and write. We know that the min is 2, 0 tens, and 2 ones, because this is going to be a standard if it doesn't indicate otherwise. This is a tens and ones thing here. So our key would say that 0, line 2, represents 2, and what's our units? Again, this is data that is unitless. Sorry, maybe in this case it's 2 inches. These are measurements. These guys are all pretty short, but then these guys are 45 and 47 inches. That's really big. Okay. So the min is 2 inches. We can even leave our units there. We don't have to write the 0, of course. And our max is, this is the biggest leaf here, it's 47. So the max is 47 inches. So that means the range is always equal to the max minus the min. So you might just kind of casually say the measurements range from 2 inches all the way up to 47 inches. However, oops, sorry, I missed that. However, in math, when we say range, that means we actually want to do the subtraction. So we say the range is 45 inches. So the 45 inches is the difference between the lowest and the highest measurements. Okay? Now, okay, we already did outliers, so underline that. Now let's look at maybe mode next. What appears the most often? I see 2 2s here. I'm not going to count this one because this means 12, not 2. I've got 2 2s, oh, and 2 zeros here. So this is bimodal. It's bimodal because there's 2 modes. So the 2 modes are 0, 2, which is 2, and also 2, 0, which is 20. 2 20s there and 2 2s there. Okay. Now, the mean is going to be the biggest pain in the butt, right? That's the mean one. We have to do all these calculations. So go ahead and get out your calculator. And remember, we have 12 numbers. So in our calculator, we're going to be putting 12 numbers in. All right. My calculator is a really cool graphing calculator. It has a lot of other calculations I'll delete out. All right. So we're just going to go ahead and add these up. 2 and 2 is 4, plus 4 more is 8, plus 3 more is 11, plus 6 more is 17. So I'm just going to put 17 in my calculator. It's okay to do some mental calculations. Now this is 11, and this is 12. So 11 and 12. This is 20, 20, and 23. So you can do 20, 20, and 23, or I'm just going to do 63 right now for this row. This is 45, so I'll do 45. And then this is 47. So when I'm calculating, excuse me, let's see, escape. I had 2 plus signs in a row, so I'm going to fix that. When I'm calculating, I get that these all add up to 195. So for the mean, I'm going to write 195 divided by 12. Now I feel like I want to do some quick mental math to make sure I didn't make an error. 63. Okay, so I think I did that right. And when I divide all of that by 12, I get a little bit of a fraction, which is going to be about equal to 1.5 hold on, sorry. That's about equal, or it is equal to 16.25. I won't round, I'll just keep it exactly 16.25. Okay? So, great, that is the mean. Now let's see, does that seem reasonable? My data goes from 2 to 47. So yeah, and it's kind of more on the left. It's just skewed out on the right here. If you turn it this way, you can see that's the right. Skewed right a bit because of those outliers. But yeah, I believe that the mean could be 16. Now, if I got that the mean was 205, I would want to think a little bit more about that. Is that realistic? My data goes from 2 to 47. Is the mean really 205? And I'd have to think more about it. Or maybe I just stop here and say the mean's 195 because I forget about dividing by the total number of numbers. So I always want to kind of check that. Okay, and then lastly, the median and the quartiles are really big for this chapter. So remember, the median is the number that's in the middle of the data points. So we're not going to look at these two that are on the far out ends, or these ones. There's kind of a strategy for how you can do this using, I'll change colors because it's always fun. So remember before when the data was all listed out in one row, we could kind of cover up the outside ones and then we could go in to find the one in the very middle. We're going to do that same sort of thing with the stem and leaf. So we're going to cross out these two here that are on the outsides. This is the minimum and the max. And then we're going to go in again and cross out the 2 and 5. And now when we go in again, that's actually these two data points here. The 3 and the 3, or the 23 technically, are going to be, so these are the crossed out. So now we'll cross out, I can even do 2 at a time actually, these two small ones and then these two ones here. And then eventually I can see that right in between here, I've got 12 data points, which is even, so my median is going to be right in the middle of two numbers. It's right in between 1 and 2. But actually, it's actually right in between 11 and 12. So my median is going to be right between 11 and 12, which is 11.5. All right. Now, when I look at my quartiles, my data has been split into the 6 lower numbers and the 6 higher numbers. So now I'm going to change my pen color and look at the quartiles. So the median is always this Q2, and I can write that here, Q2. But now I'm going to focus just on those 6 smaller numbers, and I'm going to find the middle of them. These are the 3 smallest, and then the other 3 biggest. So my Q1 is going to be right in between them, which is going to be 0 tens, and 3, between 3 and 4 is 3.5. So my Q1 is going to be 3.5 inches. These are all inches. And now my Q3, let's see, I'm going to pick these 3 data points here on the upper half. We're just looking at this stuff here. So these are 3 data points, and then here's going to be my Q3, and then the last 3 data points. So Q3 is going to be halfway between 20 and 23. So I know that to be 21.5. But if you didn't know that, you could add 20 plus 23 and divide by 2 to find the mean or the average between those. You'd end up getting 43 over 2, which is 21.5. So there's my Q3 inches. Yay! So I did my median, I did my quartiles, and lastly I'm able to do my interquartile range. So my interquartile range, my IQR, where should we write that? Let's see if you guys have space. You know, I can use a space over here. My interquartile range is always going to be equal to the range between the first quartile and the third quartile. So we're going to subtract like that. And what's going to be 21.5 minus, what was Q1? 3.5. So that's going to be 18 inches. So remember, the interquartile range looks at the middle 50% of the data. And so in other words, pretty much what we're doing is we're not counting these three, and we're not counting these three, and we're looking at the range between Q1 and Q3, and we're saying there's 18 inches that are within that range. Okay. How are we doing, folks? I think in the interest of time, I'm going to save, this is a good point, but I'm going to save it for another lesson and just kind of stay focused on where we're at here. Which is, so here's what we're going to do. I'm going to teach you a little bit about a double stem and leaf plot and a little bit about a split stem and leaf plot. And then the last thing we're going to do is just one more practice problem together that's going to help you for the homework. Okay? So it's kind of cool stuff. And these especially are two really neat variations on the stem and leaf plot, which are pretty cool. So let's focus first on the double one. Here we have our stems that are located down the middle. And then we normally have our leaves like usual on the right-hand side here for Team B, but then this data is actually comparing two different teams in the same stem and leaf plot. So Team A's leaves are going to be over here. So those are leaves, and these are leaves. This is showing us the weight in pounds of two football teams. Now, Team B is the easiest one to understand because we're used to seeing the leaves on the right-hand side. And our key says that 17 line 7 represents 17 tens and 7 ones, which is 177 pounds. Okay, but now look, this is a really weird thing for Team A when the leaves are on the left-hand side here. The 5, they're going to actually show us first because it's coming in front of the line, and the 17, but this actually represents 175 pounds. Kind of funky, right? So, for example, this one represents 181 pounds, and this one also represents 181 pounds. So these guys weigh the exact same amount. But this one represents someone who weighs 191 pounds instead of 181 pounds, for example. Okay, and then this 9 over here represents someone who weighs 199 pounds. What's nice about this, first of all, is it's just a little trick to get your brain to remember, okay, these are the stems, so these are the tens, and these are the ones, and it seems a little backwards. You might think that this 9 represented 919, but that's not the case. These are the ones. But the second thing is it's kind of neat. You can see for these two teams that this team is a little bit more skewed. If you turn it this way, they're a little more skewed left because they've got somebody who's kind of weighs just a little bit, but most guys weigh kind of more up in this range here. And then this team, in contrast, is a little bit skewed right because their highest weight person was kind of up there, but most of them are here. You could kind of say that. Although this is just 200 pounds, and this guy was 199 pounds, so these guys are practically the same weight here. But anyway, what we can really see is that for the most part, this team is a heavier team because more of the data points fall in the 200 range. This team's heaviest player is 200 pounds, represented by this 0, 200. Whereas this team has 4 players that are higher than 200 pounds. They got a 203 pound, a 205 pound, and a 207 pound, 209 pound, for example. So double stem and leaf are really nice for the double means you're comparing 2 different teams and you can see them together in the same one, which is really nice. We could go ahead and calculate the mean and the mode of these guys and compare and do all sorts of interesting things, but we'll save that for another day or another problem. And lastly, a split stem and leaf plot. So a split stem and leaf plot, rather than just having so many leaves that this flower is about to break off because there's so many leaves on this one stem here, instead what this does is it actually breaks up the 2 stem into 2 different places, which is kind of nice. All right, so this is just a normal stem and leaf plot here, but this is going to become this. This is the same data point. This one is split. Okay, so the way we split it, we don't just write 5 data points here and 5 data points here. No, the way we split it is that we put, here, let's take I'll use a color. we're going to split. The digits 0 through 4 are going to stay, and then we're going to put a line. The digits 5 through 9 are going to be after the line. So we're going to split it there. 0 through 4, okay, we're going to split this one here, and 5 through 9 are there. 0 through 4, and we're going to split it right here. 5 through 9 are there. 0 through 4, we're going to split there. So as you can see here in the note, all the leaves that are less than 5, this is a less than, but not less than or equal to, are going to end up going here. These first 5 are going to go with the first 2. And then all the leaves that are 5 and after, greater than or equal to 5, go, these guys here, go with the second 2. So you can see, for example here, these digits that are between 0 and 4 go in the first zeros column. And then these leaves here that are between 5 and 9 go right here in the second 0 column. A lot of digits are going to go in the first 1 column, and only 1 digit's going to go in the second 1 column here because of the way that those digits work out. All right? So there's one problem on your homework that asks you to do a split, and you can refer back to this in your notes in order to do that. Alright, so 40 minutes, that's my lesson pretty much for today, except I am going to do one more practice problem with you. This is what a lot of your homeworks look like, and I'm going to go through and do it with you here. I'll try to be a bit quick about it. If you want, you could do this, pause the video, and do it on your own, but I'm going to also do it for you. So I think the biggest trick here is that these guys here are not in order yet, and that's going to be a bit of an issue. So we're going to want to make sure that we get them in order. We're also going to want to notice, first of all, this is one of my big tips, is to notice how many numbers do we have, what's our sample size. And we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that's our sample size there. That means when I do my stem and leaf plot, I want to make sure that I have 20 leaves. If I don't, then I miss something. And to be honest, when I was practicing this before, I actually missed one of the leaves. But at least I knew to go back and check, so I was able to catch my error. Okay? So what I'm going to notice is the minimum. I'm going to look all around these data points. So I'm actually going to underline in green all the data points that are in the 20s. It looks like I've got a bunch of data points in the 20s. Not that one, but a whole bunch. So that's kind of where my main, that's going to be a busy stem there, my 2. But then I'm also going to notice I do have some in the 30s here, and I've got 1 in the 10s. Alright, so that means I'm going to need a 1 stem, and I'm going to need a 2 stem for sure, and I'm going to need a 3 stem. I've got so many in the 2s that would really actually make it perfect for a split stem and leaf plot, so I'm actually going to do that. I'm going to give myself two stems, so that I'm going to make this split. That'll be good to have you practice that, alright? So 19, 9 is a really big leaf, so that's good. I'm going to put it here. If it was something like 10, I would need to make another stem for the lower, like the 10 through 14 items, but this is a big leaf, so it's going to be able to go there. And I'm going to cross it off because I did it. Now I'll also do the 30s. Again, the 30s are all really low, so that's good too. I don't need to make another 3 down here. I'm going to put a 0 for 30 and cross that off. The next biggest is 31, so I'll put a 1 here, kind of spacing it nicely. And the next biggest is 32. That's my max. Okay, so I got all those. Let's look. Did I miss anything in the 10s or the 30s? No. Okay, so now I'm going to put in the rest of my numbers here. Let's go from smallest to biggest. There's no 20s, so I've got a 21. I'll put that as a 1 there. Next, I've got a 22, so I'll put that as a 2. I've got 2 23s here, so 23, 23. I've got 24, 24, so I'm going to put a 4 and a 4. Now when I jump to 25, I'm going to be able to put those in this next stem over here. So I've got 25, 25. 26, 27, 2 28s, and 3 29s. 9, 9, 9. Notice how these are kind of lined up here, so it's easy to see exactly how many I have of each, and if you turn it on its side, it's easy to see that this is the highest column here. It's kind of nice. Okay, let's double check. Did I catch all 20? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And actually, I'm going to go ahead right now and do a line there, because I know those are my lowest 10, and this is going to be my median. 1, 2, 3, 4, 5, 6, 7, 8, 9. Shoot. Look, it just happened. I missed this 29. Do you see it right here? I did it again, but at least I caught it. Okay, so there are actually 1, 2, 3, 4 29s. So I need to add another one there. Good. So now I've got all 20 of them. There are 20 classes in the school. There's 20 data points here. Remember, each of these data points is the size of each class. So this class only has 19 kids. That's nice. This class has 32 kids. That's pretty big. Our class is much smaller than that. Yay, Live Oak. Okay, and we're ready to go. So what is the range of classes? Well, the max is, like we just said, it's 32, represented by this leaf here. The min is 19, represented by this leaf right here. So the range is going to be, let's see, 32 minus 20 is 12, but we're only subtracting 19, so it's 13. All right, mental math. So our range is going to be 13 students, because these are class sizes of the number of students. So there are 20 classes. The range of sizes is 13 students. So again, another way to think about that is the difference between the smallest class and the largest class is 13 students. Okay. What is the most common class size? Most common is the mode. And remember, there were 4 29s, so many of them that I didn't even catch all of them. So 29 is kind of the students, a class size of 29 students is the most common. What is the median class size? So the median is, I actually already did it. Remember, I counted, you can go ahead and cross off like this if you want, like I did before, but I actually counted the 10 data points, and then I put a line, and then let me check again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So the median is going to happen right in between here. If there was an odd number of class sizes, then the middle number itself would have really stood out. But again, there's an even number, so I'm going to put my line there. So the median is going to be between 6 and 7, which is 6.5. But not really. This is in the 20s row. So it's actually 26.5. This means 26, and this means 27. So this is going to be my median here. 26 and a half students. Can't really have half a student, but that's okay. All right, now we're going to go ahead and calculate Q1 and Q3 as well. The median is Q2. Q1, I'm going to look at these 10 points, which again is an even number, so I'm going to look at the bottom 1, 2, 3, 4, 5 and do a line. And then here's the middle 1, 2, 3, 4, 5. So this is going to be my Q1. This was already my Q2, and then I'm going to count 1, 2, 3, 4, 5. Q3 and 1, 2, 3, 4, 5. Okay, good. So Q1 is going to be between 23 and 24, which is 23 and a half. And Q3 is going to be between 29 and 29, which is just 29. Nice and easy. Students would be the units. So the interquartile range would be 29 minus 23.5, which is going to be 5.5 students. And then lastly here it says to find the mean class size. So the mean one is really mean because you got to add them all up and divide by the number of numbers. So you'd have to add all these things up and then divide by 20. So it would be the total divided by n, which in this case n is 20. And I'm going to go ahead and let you add that up yourself. It does say to draw a box and whiskers plot, which we're going to continue to talk about, so I'm just going to do this one example here. We said that our min was 19, so I'm going to put a dot at 19, and our max was 32, so I'm going to put a dot at 32. And then we're going to do our quartiles. 23.5 is one quartile. 29 is another. And 26.5 is another. So these three are going to make our box. And then our whiskers are going to go out to the min and the max. So there we go. Now the one really important thing that I haven't discussed yet that I need to before you do your homework, is the idea of how the mean and the median are related to each other and really affect each other. So let us go back to this page here. Okay, we're going to look at this data that we've already done a bunch of calculations for. And we're going to look at how these outliers really affect the data. So we said that the mean was 16.25 and the median was 11.5. Gosh, if you wanted to argue that these are really high numbers, you would point out that the mean is really high. It's 16.25. But if you wanted to point out and you maybe argue that, you know, these were too low, that they really should be higher, you'd say, yeah, but the middle number, the median, is 11.5, right? Why is the mean so much greater than the median? That is what we want to understand, and that is what is asked in your homework when we're talking about how the outliers affect the data. Okay? So these two really big numbers here, 45 and 47, are making this number really big up top. So it's giving us a pretty big mean. But they don't really affect the median. What if, for example, instead of 45 and 47, these two numbers were, let's say that they weren't way out here. Instead, they were back here. Let's say they were maybe 24 and 25, for example. That is not going to change our median one little bit. The fact that these two numbers are now actually really small. All our median cares about is the middle number. It doesn't care what these numbers are. It just cares that those numbers are there. So we can still look and say these are the outermost, then in, then in, then in, then in. So our median is literally still right here. It has not changed. However, our mean has changed a lot because now when we calculate the total, we're not going to add 45 and 47. We're only going to add 24 and 25. So now our mean is going to be a lot smaller. So what it means if the mean is a lot bigger than the median, okay? And you know, I could even write this out here, but I don't want you to, I'm going to write it, but I don't want you to rely on this. I want you to understand what it means. If the mean is a lot bigger than the median, which is what is the case here, what that indicates is that there's probably a large outlier, or outlier or outliers, because those big numbers really dragged the mean's total up a lot, and it didn't really affect the median very much. But in contrast, if the mean is a lot less than the median, that probably means that we have some small outliers. So there maybe were outliers in the small, on the lower end of the data. Okay. So what we could do then is recalculate. Sometimes in your homework it'll say, why don't we just not even count these numbers out here at all? If we didn't even count those, we just discounted the outliers and didn't consider those, and we said, oh, those two guys were super long or super big or whatever, but that's not representative of most of the data, so we're just going to look at the most of the data stuff here. Then it might ask you to recalculate the mean and see how the mean is affected, or recalculate the range. So without these two data points, the range is from 2 to 23. That's just a 21 range. But here, the range is 45 because of these big outliers really stretching it out. Okay? So go ahead and do your homework now that you've learned this information. You're not going to need this stuff for your homework, so that's fine. And if you get stuck, look in the book, look in your class notes, or if you really get stuck, my key is always there that shows all of my work written out really nicely for you. Okay? Good job, guys. I'm going to let you out 30 seconds early.